Okay, so let's continue our discussion on another method for time domain analysis of discrete time system, what we call difference equation. So it's very important equation for design and analysis of LTI discrete time systems, this difference equation. As we have discussed, analog signals or continuous time signals, we use differential equation. We have discussed the previous class. But for discrete time systems, with the equation, we call it difference equation. So let's see one more example on difference equation. So I think this is example 3. So let's take a system with input x of n. This is our input signal connected to one of the basic elements of a discrete time system. We call it adder. This is adder circuit. So adder circuit, it takes two inputs, one from here, another from input side. Okay, so when you see adder, one of the basic element in discrete time system design, so it takes two signals, discrete time signals, x1 n, x2n as input. So what will be the output of this circuit element? X1n plus x2n plus x2n. Okay. So that's one of the basic elements in discrete time. Just like when you see continuous time systems, we use capacitor, resistor, inductor. It's the basic components. But here, discrete time system, one of our basic component is this adder. So, one, as you can see here, one of the signal is our input, okay, of this for this signal. Another signal comes from output side. Look here. So this another circuit element, the symbol is z to the power of -1. This is our y of n, which is the output, right? So from the output signal, look here, go back as a feedback. Okay, as a feedback, we apply for this unit delay system. Z, this element is called unit delay element, okay, or memory element. So what is the function of this element? If you have this memory element, this is the symbol. If you give it a signal x of n, then the output will be the input signal just delayed by 1. What does it mean by delay? It is a past value. Okay. We apply input now because it is a memory element. It will store the previous samples, and it will give you one sample before. That's why we call it unit delay. It's delay by 1 unit time. Okay. So this y of n output connected to the z to the power of -n. So what is the signal output of this unit delay element. What is the input? Input comes from Y side, so it is Y of output comes. It's a feedback. I think you are familiar with feedback. Feedback means output go back to input. Now this Y of n comes here. Apply to this unit delay. As you know, unit delay only shift by 1. So what will be the output here? Y n. What is the input? Delayed by 1, which is the past value of output, which is now connected to the adder here, but we use negative feedback. There are two types of feedback. If this is positive, it will be positive feedback. But now we are using negative feedback, so this will be minus here. So what is the signal at this point? Look here, the output is delayed by 1. It comes to this point. Input comes from this side. So this is adder. It will add the 2. It will add the input, and it will add the delayed output. So what will be the signal here? X of n, not plus, we use minus. Why? Because here you see it is minus, not plus. Negative feedback. So what is this signal? This signal is output delayed by 1. Okay. Then this signal comes here. At this point, we use another circuit element called multiplier. Okay. So another circuit, very common circuit element. Circuit element is a multiplier. The symbol looks like this, just an arrow by some constant A. So what is multiplier means? Any signal you apply as input, what will be the output of this multiplier? It's multiplied by A, the constant. Okay. So what are the 3 basic elements in discrete time system design? Adder, memory unit, which is unit delay element, and multiplier, just like capacitor, inductor. So look here. So now what is the signal at this point? Because here we have a multiplier which is multiplied by 4. This element is multiplier. Okay, this element is multiplier. So what is signal at this point? The input, the incoming signal, which is output of this summer, is this one, which is multiplied by 4. So 4 times x of n minus, again this also multiplied by 4. 4 times y of n minus 1. Then this signal output of multiplier goes to what? Output here. So that is equal to what? It will give us y of n. So here we write the difference equation for this simple system. So what is the difference equation for this simple discrete time system? The difference equation is what? Y of n is equal to this y of n here is equal to 4 x of n, right, minus 4 y n minus 1. Okay, so if you collect output on one side and input another side, take this on the other side. So negative becomes positive. So y of n plus, now it becomes plus because this minus becomes plus. Y of, sorry, 4 times y of n minus 1 is equal to this one for input on one side, output on one side, input on another side. So this equation is called difference equation. Okay. Difference equation of this simple discrete time system. Not differential equation. So what's difference equation? Equation which relates output with input. You see this in this equation. We have only y of n, which is output, yn minus 1, which is also past value of output, and x of n, the present inputs. Okay. So equation which relates output with input for discrete time system, we call it difference equation. It's very important equation. We'll discuss why this equation is very important. So now let's see the general form. General form of difference equation. General form of difference equation. Okay. So let me write the general form of difference equation. I will explain okay, so on this side, it's linear summation of output on one side. As we have discussed before, difference equation which relates output with input. So as you can see this equation, on one side we write outputs and the other side inputs. Okay, equation which relates outputs on one side, input on another side. So on this side we have all outputs, as you can see here. This is y of n. What's y of n? N is our present time, a time at this moment. Okay, with coefficient A0 constant. What is the next one? Yn minus 1. Output before one sample time. Okay, if our sample is 1 second, what is the output before 1 second? Yn minus 2. Output before 2 sample time. So all these are past value of outputs, but this one is the present output. Okay, summation of all this, because as we said, superposition for linear system, superposition means summation of all inputs must provide summation of all outputs. So how much is n? N here, you see capital N is order of the system. It's first order, second order. I will come to that. So on this side, similarly, input side, let's start from V0. Input at present time, x of n plus V1 input n minus 1, which is past value of input, plus B2 x n minus 2. Okay, the input before the past value of input before 2 time periods. Okay, plus, so up to Bm x of n minus n. I will explain this using example. Okay, so look here. This is a general form of difference equation, general form. So this A0 on the output side, the coefficients A1 up to what? Up to AN on output side. On input side, we use B0, B1. These are also coefficients. B0, B1 up to what? It goes up to BM. Okay, BM. So these are coefficients. Coefficients on which side? On the output. Okay, on the output side. These are B0 up to BM, also coefficients on the input side. Okay, now if these coefficients are linear constants values, they are not dependent on time. Linear, if they are linear constant coefficient on our equation, constant coefficients. Okay, if your equation, when you develop equation, and these constants, these coefficients are linear constant, our system is what? Our system is linear. Linear time invariant system. Okay. The system will be a linear system. What is the condition to be linear system? These coefficients are, if they are constants, they don't depend on time. We call it the system linear system. We'll see example. What is the order of this system? Order of the system. The system depends, it can be first order, second order, third order, and so on. So when you see the output side, this is output at present time. This is output delayed by 1, past value of output. How about here? Output delayed by 2, past value of output before 2 seconds up to what? It goes up to n. Okay, the output depends up to n past values. N past values. It can be 10 samples before can be depend on 8 samples before. That is the order of the system. So n, as you can see here, this n on the output side, and input side, you see here, this is the present input, but the output depends not only the present x of n, present input, it depends on x of n minus 1, past input. It also depends on xn minus 2, past input before 2 time periods, up to what? Up to m here. So this n and m are the order of the system. Okay, mostly we use n. Now, if n greater than m, okay, if n is greater than m, our system is called causal system. System is called what? Causal system. Okay, so let's see. Number one, if you see this equation, y of n minus 3 y n minus 1 is equal to 2x of n plus half x of n minus 1. This is one example of difference equation. Okay, so this is out. What is the order of this system? Look here. This is the present output. Depends on what? Output before 1 second, 1 sampling period, not second. Plus, here is the input. Here is input before 1 sampling time. Right? So, what is the order of this system? What is n? N is only 1 here. You see, it is only 1. How about m? M is also 1 here. So this is the, or n, and if n is greater than or equal to m, our system is what? Causal system. So this system is causal system with order 1. This is first order difference equation. Is it linear or not? In order to check whether the system is linear or not, we have to check the constants, coefficients. What's the coefficient of y of n? 1. Coefficient of yn minus 1, minus 3. So what is A0? A0 is 1. Okay. So A0, as you can see here, is the coefficient of y1. Coefficient of yn minus 1 is A1. So how much is A1 here? Minus 3. A1 is equal to minus 3. Okay. How about B0? On the output, B's are coefficients on the output side. B0 is the coefficient of x of n here, which is 2. How about B1? You see this general equation, B0 is a coefficient of x of n, B1 is a coefficient of x of n minus 1, and so on. So how much B1 here? It is half. So when you see these coefficients, they are what? They are constants, right? They are constant values. If the coefficients are constants, we can say our system is linear system. Okay, the system is called linear system. Okay. So let's see another difference equation too. Y of n, this is equation for another system, plus 3 y n minus 1 minus 0.5 y n minus 2 is equal to 1 over 4 x of n minus x of n minus 1. Okay, let's see this difference equation. See this difference equation, output on one side, input another side. It's difference equation of a discrete time system. So what is the value of n here? N is now how much? N is 2. So the output is delayed up to what? Up to 2. N minus 1, n minus 2. So maximum delay will be 2. How about M? M is this input. Input is delayed up to only maximum 1. So M is 1. So here you see N is greater than or equal to M. So our system is causal. Okay, it is a causal system. You know what that means by causal system? System only depends on past and present inputs. It does not depend on future. Okay, causal system. Is it linear or not? So to check linearity, we have to check the coefficients. What's the coefficient of y of n? We call it A0, right? In our general equation, 1. Coefficient of yn minus 1, we call it A1. How much? It is 3. Coefficient of yn minus 2, we call it A2, which is minus 0.5. Okay. How about output side? B0, the coefficient of x of n, B0 is 1 over 4, 0.25. B1, the coefficient of the x of minus 1, which is minus 1. So all these constants, right? They are constants. They are not dependent on time. So if all the coefficients are constant, linear constants, our system is linear. Okay, so just by looking the equation, you can say the system is linear or not. You can say the system is causal or not. This equation gives us so much information about our system. You can determine whether the system is linear or not, causal or non-causal, time variant, time invariant. System properties can be determined from this very important equation, what we call it a difference equation. Okay, let's see one more. So y of n minus n y n minus 1 minus 2 y n minus 2 plus y n minus 5, okay, is equal to x of n. Okay, so let's see this equation. This is also a difference equation. So what is n? In this case, n goes up to what? Up to 5 here. You see 5? That is the maximum delay on the output side. M. Is there any delay on the input side? No, only the input. So M is 0. There is no delay here. No delay. Only we have x of n. The present input affects the system. Okay. The past value of input does not affect the system. But here, the last, this is the present output. How about these 3? They are the last past values, 3 past values of recent, the last recent 3 output values affect the system. Present input affect the system. That's what we understand from. So these are last 3 recent outputs. Recent outputs, right? How about this one? The present output. How about this one? It is only the present input. There is no past value of input in this equation, as you can see. So this is a present input. So it depends on your system, digital system. The system can be dependent on present input only. In some cases, system depends on the present input value plus memory, past values. Similarly for outputs. The output at this time may depend on past values outputs or not. So what is the order of this system? 5th order. So this system is, we call it what? 5th order difference equation. Difference equation, right? 5th order difference equation. How about this one? This one, what is n? N is 2. So it will be 2nd order difference equation. This is 2nd order difference equation. Okay. So how about this one? Because n is 1 here, the output only delayed by 1. This equation is, it is what? 1st order difference equation. Not differential. Differential for continuous time systems. Here we call it difference equation. 1st order, because n is 1. You see, n can be 5th order, 6th order. When you say 6th order, the output depends on the last 6 samples. Okay, depends on the system. For analog systems, if you see system only wins 1 resistor and 1 capacitor. Okay, 1 resistor and 1 capacitor, CR. Output, let's say y of t, input x of t. So if you see equation, differential, not difference in this case, dy by dt plus rc y of t is equal to x of t. So this equation is what? This equation is, because first derivative here, we call it what? First order differential. It's called differential. Differential equation. Okay, differential equation. Now, when you see a system with R, L, and C, system which consists of three components, R, L, and C. So this is the output, okay? Y of t output. This is input, X of t. This is for continuous time system, okay? Now, if you write the equation which relates input and output, it will be what type of equation? D squared y of t by dt squared plus dy of t by dt plus y of t is equal to x of t. What type of equation is this? It is differential equation, but it is what? Second order. We call it second order differential equation. This is for analogy. Similarly, for when you come to discrete, we'll have first order discrete difference equation, second order difference equation. As you can see, this example 3, it is fifth order difference equation. Another point, this this system, which is y of n minus n y n minus 1 minus 2 y n minus 2 up to what? Up to 5. N minus 3, n minus 4 is there, not 0, because the coefficients are 0. Is it linear or not? Look here. The coefficient of y n minus 1 is n. So what is A0? A0 is the coefficient of yn, which is 1, constant, it is okay. But A of 1, the coefficient of yn minus 1 here is n. It's not a constant, it depends on n. N is what? Time. So because of this, if one of the coefficients is not constant, the system, our system is what? Our system is non-linear. So this is the equation of non-linear system. Non-linear system. Why it's non-linear? Because one of the coefficients here is n. It's not a constant number. All the coefficients on the output side, A0, A1 up to n, all coefficients on the input side, if you see this general equation, A0, A1 up to an on output side, and B0, B1 up to Bm on the output side, all the coefficients must be constant. If they are constant, our system will be linear. But if one of the coefficient is not constant value, then the system becomes non-linear system. Okay, let's see one example here. We have a system. What type of system? Discrete time system. This is input x of n, and this is output y of n. So the equation, difference equation of this system is given. So the difference equation is y of n minus 2 y of n minus 1 is equal to x of n, this is input side, plus half x of n minus 1 is given. Okay, it's given. So here, initial condition, initial condition y at -1 is given. The output at y -1 is given, which is 3. The difference equation is given. Input is given. This input value x of n is given. In this case, it is unit step. We apply discrete time unit step signal as input. Okay, as input. So what is x of n? Is equal to u of n. You know u of n. This unit step sequence, which means all sample values are 1. Start from 0. Start from 0. All sample values are amplitude 1. 1 here. At +2, again it is 1. So it continues up to infinity. This is our n. How about for n less than 0? At -1, at -2, all sample values are 0. This is unit step. So input is given, difference equation is given. We are asked to determine the response, the output of this system. What is y of n? That is the question. We are asked to determine y of n for this system. So that's why this equation is important. You know, using convolution, impulse and input given, you can find output. Similarly here, from the equation, difference equation, you can calculate the output of discrete time system. Before that, is this system linear or not? So let's check the coefficients, right? What's the coefficient of y1, which is a0? It is 1. Coefficient of yn -1. It is a1. How much? It is -2. Okay. Output side, sorry, input side, b0. These are coefficients on input side. A's are coefficient on output side. So coefficient of xn is 1, b0. What's the next? The next one is b1, which is half. So as you can see here, all the coefficients are constant. So we can conclude our system is LTI system, linear time invariant system. Okay. What is the order of this system? It's only delayed up by 1 maximum output. So n is what? For this system, n is 1. What is m? M is also 1. So this is it is first order difference equation. Okay. It's also causal because n is greater than or equal to m. Not difference, not differential, but we call it this difference. We call it difference equation, first order in this case. Okay. So we are asked to calculate the output here. So let's see from our equation. what's our difference equation? Y of n minus 2 times y n minus 1 is equal to x of n plus 1 over 2 x n minus 1, right? This is a given difference equation of the system. Now take this on the other side because we are calculating y of n. So what will be the output at present time? Okay, if you take this on the other side, it will be plus. So it will be plus 2 y n minus 1. How about the input side? Plus x of n plus 1 over 2 x of n minus 1. So what do you understand from this equation? Output at present time n depends on output before one sampling time, the past value. It depends on x of n input you apply at this time. It also depends on input you apply before one sampling period. You see, the present output y of n depends on the three samples. Past value of output, present value of input, past value of input. So, what will, when n is equal to 0, what will be the output? Which means when time is 0, what will be y of n? So 2 times y, when you substitute n 0 here, 0 minus 1, it will be minus 1 plus, now we are substituting n is equal to 0. We are calculating for time 0, what will be the output? So here our input will be x of 0, n is 0, okay, plus half of x, xn minus 1. When n is 0, it will be x of minus 1. Okay, so how much is y of minus 1? Here you see initial condition is given. The output at minus 1, how much? 3. So it will be 2 times 3. Y of minus 1 is given. Plus, what is the input at 0? Go to your input. At 0, this unit step at 0 is what? It is 1. So this value is 1 plus half times what is x of minus 1. Go to your input. What is the input x at negative 1? This is unit step. We apply unit step. So at negative values, the sample is what? 0. X of minus 1 is 0. So 2 times 3, 6 plus 1. This is 0. Okay. So how much it will be? 7. Okay. So look here. When n is equal to 0, output is equal to 7. Okay. How about output when n is equal to 1? The output of this system when the time n is equal to 1. So from our equation, we are using this equation. Okay. So y of n from our equation, what is y of n? Is equal to 2 times y n minus 1. The equation is given plus x of n plus half half x n minus 1. Okay, so let's calculate now for n is equal to 1. So it will be y of 1. Output when time becomes 1 is equal to, substitute n here 1. What will be this? 2 times 1 minus 1, it will be 0, plus x of 1. X of n becomes x of 1 plus half x of, when n is 1, 1 minus 1, x of 0. Okay. So what is y of 0? Here, y of 0. We calculate it in the first step. Y of 0, we calculate how much? 7. So 2 times 7. Look here, it's very important. Output at n is equal to 1 depends on output at n is equal to 0. Before 1, it's memory before 1 sum. How do you know why 0? We calculate before 7. So substitute here. Okay, this 7 will be substitute here. So how about x of 1? Input when time becomes 1. You go to your input signal, it's unit step. Unit step amplitude is 1 plus 1 over 2. What is x of 0? X of 0 is also 1. Unit step at time 1 is 1. So how much this is? 2 times 7, 14 plus 1 plus 0.5, right? 1 over 2 times 1 is 0.5. So how much is this? 15.5. This is output of the system when n is equal to 1. So you continue like this. We calculate the output like this from the difference equation, but it's iteration, right? Y of, you calculate y of 0, y of 1 depends on y of 0, y of 2 depends on y of 1, right? Now if you calculate one, let's calculate one more. When n is equal to 2, when n is equal to 2, what will be the output? Y of 2, okay, is equal to, here, look here, y of 2 when n is 2 is equal to 2 times yn minus 1. So yn minus 1. So n is 2 now. 2 minus 1, it will be y of 1. Plus, output also depends on input, present input and past inputs. So when n is 2, so it will be x of n becomes x of 2 plus half x of n minus 1. So when n is 2, 2 minus 1 will be x of 1. Okay. Now 2 times y. What is y of 1? We calculated here. Y of 1. Now put it here. How much we get? 2 times 15.5. It's very common for engineering systems. Output depends on past value of output. What we call it feedback. Very important concept, feedback. So look here, I am feedback. Y of 1 depends on what? Y of 1 depends on y of 0. Y of 2 depends on y of 1, the past value. What is x of 2? X of 2 is our x is input. So check your input given impulse response. So for all positive values of n, impulse is 1. So x of 2 is 1 plus half times what is x of 1? X of 1 is also 1. So how much is this? This is 31 plus 1 plus 0.5, we get 32.5. This is output when time becomes 2. So like this, you can calculate any output values at any time you want, but it is time consuming. Okay, so in MATLAB there is one function called filter. Filter, what is B? B is, what are B's? B's are coefficients of the input side. This is a difference equation. What are A's? A is coefficients on the output side, A0, A1, right? Look here. In this example too, for example, what are A0, 1, A1, 3, or coefficients. B0, B1 is given. These are A coefficients. In this general equation, you can see A0, A1 up to AN, coefficients on the output side, B0, B1 up to BN, coefficients on the input side. You give this to the MATLAB. Here, B and A are coefficients of the difference equation. What is X? X is our input. So from the difference equation, just by write this one command, filter, you will calculate the output of this system. Here I showed you manually, right? How you do it by your hand. Calculate output from the difference equation. Using MATLAB also, you can use, as you can see here, we use what? Filter. So you get the output. It will give you the output. What is B? Coefficients. What is A? Coefficient. These are inputs, which is impulse input. Then you can calculate by this command. Okay. As you can see here also, we use command filter B, X. This one command, if you have any difference equation, you can determine. Look, this is the response of this system. The MATLAB will calculate and plot the output of any discrete system if the difference equation given for linear time invariant systems by taking only coefficients of the equation, apply your input, you can calculate the response or output of the system using a command called filter. We'll see this next class.